So for those who were not on my yesterday's presentation, I am Andrew Slivker, Chief Technology Officer of the company Nivatech out of Atlanta, Georgia, United States. So today I'm going to be talking about the interesting concept of security mediation for APIs specifically. What is that? What is actually security mediation? Why do we need it? What are the benefits, challenges, and how to address them? And I'll be also showing it in practice, kind of through live demo, using API management software called Sentinet from Nivatech that would kind of prove and demonstrate the concepts that I'm talking about. Let me start my timer. Okay. So first, on a simple conceptual level, when we deal with consumer and API, consumer application and the API itself, we know that we have to deal with security, and basically, in few words, the complexity lies on two sides. The client application has to what we call implement security, because it's a client. It has to make sure that it's properly, forming all the security tokens that needs to be sent, or attaching certificates, or injecting username, password, or API keys. And on the provider side, the challenge is to make sure that this security is enforced. So in both cases, it requires potentially some coding, configuration, maybe both. So these are all kind of typical traditional challenges. If API consumer application and API itself are entirely under your control, it's a little bit easier because at least you can agree what kind of security you should implement and control to a certain degree complexities of the security aspects. If you, let's say, API consumer and you have to call somebody else's API, you have to comply to what API requires, and that means that there is no much leverage on your side. You have to do whatever API asks you to do. Similar thing might happen if you actually provide the API. So you have to keep in mind what capabilities will be required from the client when you design. And of course, scaling up security, that presents additional level of challenges because you might have a whole bunch of APIs, a whole bunch of different consumer applications. These security models can be all different. So now everything multiplies. And we know that API gateways promise us to help us address all these complexities by encapsulating both sides of security within the realm of the gateway itself. Even though at the first glance it might seem that complexities multiply, because now where you used to have just one security model, you might have potentially two security models. So you have two network communication legs, and each of them can be subject of security. This can be the same security, or they can be completely and entirely different. So in general, there might be some security mediation that will be executed by the gateway itself. So on the inbound side, when consumers talk to the gateway, it can be any security. I'm giving examples of username, password, certificates, Kerberos, and TLM, JWT token for auth, API keys, or anything custom. Similar things can be on the outbound side, and they can be different. So it's many-to-many relationship. You might be username, password coming on one side and auth token on the outbound side, or vice versa. So if the gateway is capable of mediate with all these different directions, that means the gateway in the first place is much more capable to address your specific scenarios and needs. So within the gateway, we actually host all these virtual services. So what about scalability? Again, it might sound that scalability issues actually rise, not diminish, because you have again inbound and outbound, and a whole bunch of different security cases permutations. But in reality, actually, gateway helps you to simplify things because you can standardize, and it depends who owns actually the gateway. And when I say own, that means who has control over the gateway itself. Is it you as a provider, or you are actually consumer and you also own the gateway? So let's say if you are a provider and you own gateway, so the dashed line kind of shows the scope of ownership. You might want to decide to standardize on how you develop and deploy your backend system, what kind of single security is going to be there. So you're not dealing anymore with all the varieties of different security models. And when you deploy and put the, through automated deployments and further management of APIs, you always stick potentially to exactly the same unified security. And then the gateway is configured, and that configuration is dynamic and remote. You don't have to do any coding. The gateway is configured to expose each individual service exactly according to individual, service requirements that are imposed on a consumer applications. Similar story happens on the outbound side, meaning that if you own gateway as a consumer, you have to consume somebody else's API. You can unify the way your own applications deal with gateway. They might be, let's say it's a gateway running on premises and it's running, and you need integration with Active Directory. So you just, can use local Kerberos and Active Directory integrated calls all the time, and then make sure that each of the virtual service configured with the security that is required by the relative, corresponding external backend service. So we have, as an example, customers that exercise this scenario when they have to call Salesforce.com API or Google APIs, or Microsoft commercial APIs. And sometimes they have to deal with different APIs at the same time. They all have different security models, and even if security model is different, still it needs different configuration because Salesforce has its own OAuth server, Microsoft has its own OAuth server, and so on. So the gateway really helps you to do that. So the scalability can also be addressed by the gateway to giving you opportunity to unify and simplify your own job. Another interesting aspect is actually modernization of the security models. So you might have today, running your APIs or planning to run them on a relatively simple security models, classical, traditional, but you are looking to modernize security models and take advantage of the benefits that they provide. Let's say we all know about OAuth. We've heard about it quite a lot, and even during this event, we've seen quite some presentations dedicated to that, because OAuth provides by itself as a concept significant benefits, but these benefits come at a price. The price is to actually deal with OAuth. So let's say a very simple scenario, what happens in a very simplified kind of story. So you have consumer, it needs to make OAuth call to the API. So first it needs to somehow interrogate and communicate with OAuth server itself to exchange credentials for the OAuth token, and only after that it will send this token to the API. And in fact, this interaction, despite the fact that it seems simple, it might include a lot of additional complexity piled up on top of each other. For example, you don't want to make calls to OAuth server all the time. Every time you need to send a message, you might want to start doing caching of these tokens. And caching might depend on the capability and instructions from OAuth server itself, how long these tokens are valid for. The tokens might expire, might be revoked, so you have to deal with that as well. That all has to be buried inside your client application implementation. So yes, at the end of the day, you will get OAuth. But as far as reaching that point, you'll have to, there is some price tag attached to it. Similar thing on the, if you are writing an API that you want to, enable with OAuth security, you have to, program your API in such a way that it can understand OAuth token received, validate it, disassemble all the claims that contained in it, and in some cases even also interrogate OAuth server for the purpose of validating the tokens. Some tokens are do not really contain claims. They contain reference tokens, so it needs to be sent to OAuth in order to be exchanged for actual claims. And even for the purpose of validating, there still might be interrogation to learn about the auth server capability. So gateways, API management concept and gateways as part of this concept can also help you with that level of modernization. So let's say again, you as a consumer, you have to call somebody else's API that requires auth, security, modern security, and you have a gateway that you own, that you control. What you can do, you can communicate with that gateway locally or across the wide area network using any security you want. Any simple, and then delegate responsibility to deal with the auth to the gateway itself. And that delegation requires only simple configuration in most cases. So the gateway will take responsibility to interrogate the auth server, learn everything about that server, receive tokens, cache them when needed, refresh tokens when needed, and then attach the message to and send it to provider. Similar picture if you are again API provider, you have your own API. You can deploy and develop your API with no knowledge of auth whatsoever, and let gateway to make a local call to your, and I mean local meaning within maybe your local network, right? Not necessarily the same machine, of course. Local call using whatever security you want, whatever simple and still yet security, I don't know, username, password, X509, API keys, and then let a gateway deal with the auth token that it receives from the client that we assume that already done its own part of the job. So again, your API deployment becomes really simple. So I'm going to show you a little bit of demo that actually indicates that kind of shows that modernization at very little expense. And as you can see on this slide, this particular use case shows a gateway that helps API to deal with auth. Previous slide was showing how it helps client to deal with auth security. And in the demo, I'll try to combine both just in one demo use case, only for presentation purpose and for simplicity. So what I'm going to do in the demo, I'm going to, oops, I'm sorry, not thank you yet. I'm going to take a simple client, and in my case, it will be just a browser. No security, it sends message from the browser, a simple HTTP GET. On the other side of the equation, I have a backend service, physical service. Again, it doesn't have any security. In my case, it will be public endpoint of some sample service from Microsoft Basic Calculator that runs in Azure. So anybody can call it. And I'm going to lock down the entire security within the Sentinel API gateway. And what I'm going to do a trick. I'm going to virtualize API twice. So first, I'm going to create one virtual service that helps API provider, and then I'm going to virtualize it again. Virtualize already virtual service, so it will simulate help to the client. So in the course of messages flowing, the first virtual service will be responsible to act on behalf of the client, talk to Azure Active Directory, and actually in this example, in this demo, I'm going to be using Azure Active Directory as an auth provider. If gateway is good enough and capable enough, then it should not matter who is external provider. It can be anything, and that's certainly true for the Sentinel, our product. We can support any auth provider, doesn't matter which one, what's the vendor, who is provider, as long as the auth server, auth provider runs on the standards. And Azure Active Directory is one of those that are entirely run on the standards, satisfy the standard communication protocol, auth. So it's going to talk to that one and then send message to provider where it will be validated. Again, this guy also will interrogate, and I'll show you later why, but only on a very rare basis to learn configuration of the STS and dynamically bind itself. And then the message will be flown further down the road. So we're going to switch to the demo virtual machine. Ah, I should stop probably PowerPoint. Okay. And the entire process is controlled off the Sentinel console remotely and securely controls the gateway. So I'm going to show you where I registered first services. I placed them in hierarchical folder of the repository. I just, for my convenience, organized them by different folders to group services logically. So this is my Azure Basic Calculator service registered in the repository. So that's the end service. You can see that its endpoint is in the cloud. That's Windows Azure address. Then I'm virtualizing it for the first time with the first virtual service. And I'll show you how it was done for those who haven't seen it. So that would have been, I'm going to erase what I've done. That would have been initial design of the virtual service. In reality, all it takes is just drag and drop saying that I'm going to virtualize that Azure Basic Calculator. And then you'll have to pick up one of the gateways if you have more than one, drop it on inbound points and start configuring the endpoint of the gateway itself. So you pick the transport, HTTP, HTTPS, and then you go and start configuring security policy. That's where the OAuth all goes into. So you can select from predefined policies, and you can find policy that is called OAuth service side. And if you look at that policy, I'll show it full screen, it's just a whole bunch of XML that actually provides this configuration. But in this case, and I'm going to cancel everything I do by hitting refresh and come back to already pre-configured case. If I look at the endpoint and I look at its policy, what I will see is a very, very simple XML fragment. That's how Sentinel is configured with all sorts of security policies. This one is OAuth. That's why we have this XML element that's called Web Auth Security, but that's not important. What's important? What is that actually we provided this policy with? What kind of information is there? Well, it says that the token should be expected in a JWT format, nothing fancy, and then there is some kind of an endpoint address. And you might be wondering, is that it? And the answer is yes, that's it. Why? Because this is the endpoint of the OAuth server. So the OAuth server from Azure Active Directory running on the standard, and it's so good, so nice, I would say, that it gives an endpoint that self-describes that OAuth server in a standard way. So all we have to do is to configure gateway with that endpoint, and this will automatically give chance gateway to learn at runtime everything it needs to learn about the OAuth server. All their other endpoints, certificates that will be used by the server to sign a token and so on. So it is as simple as that. So even in this case, even configuration within the Sentinel, within the gateway, is quite simple. So that's what we do on the service side. Now let's take a look now for at the next virtual service. So the next virtual service, I put it in a different folder. Oops, I'm sorry. Let's keep this one. Well, it's okay. I'll put it on a different folder. I think it's in this one. I called it First Basic Calculator because it's the first service that will be called by the client according to the message flow. So for that service, I did exactly the same thing, and only the outbound endpoint now needs to be configured with OAuth. Let's see what it is actually configured, how the policy looks like. And if you look at that policy, there is nothing much. There is still the same address of the OAuth server. And in fact, in this case, you see, it's login.microsoftonline.com. That's what it starts from. So that's, yeah, 1 minute. Oh, yeah, sure. So, and then client secret, client, credentials. So I'm going to make a sample request really quickly, and given the internet connection is good, so it might take a little bit of time initially because there has to be all these interrogations done on the fly. And then you see we have the request, and then I'm going to hit refresh again. And this time it's much faster. If I go to the monitoring, and I'm going to monitor it from perspective of the entire gateway in this case. So I can see all these two messages. If I look at the monitoring of these messages, what I will see, this is the first basic calculator is called. There is nothing, in the original request, but if you look at the outbound request, we already see authorization header. That's the header that contains the auth token already. Moreover, if we have enabled tracing, we can trace and see how the gateway actually interrogated the auth server and received the token. Now on the inbound, on the receiving side, and that will take only a second to look at that, we have the message. Where is that? Yes, we have the message that actually received all the claims from auth server. That's it. And by the way, you can see that first it was taking long time because of these interrogations, and the next pair of messages went much faster because everything was cached by the gateway, everything that had to be cached and could be cached. So that's, again, a good demonstration of how gateway encapsulated complexities of security and helps you to move to modern security without applying any effort on your side, whether you are consumer or provider. That's it. Thank you very much.
Excellent. Thank you, Andrew.